Okay, so for
Or
example,
change in momentum.
excuse me. For example, 8.11, I believe this is. Yes, 8.11. We have a ball is thrown with a mass of 40 kilograms against a brick wall. It hits the wall moving horizontally to the left at 30 meters per second, and it rebounds horizontally to the right at 20 meters per second. Find the impulse of the force exerted on the ball by the wall. If the ball is in contact with the wall for 0.010 seconds, find the average force on the ball during the impact. So this is 8.11, and first they're wanting us to find, so two main things we have to find. We have to find the impulse, and we have to find the average force on the ball during impact. Okay, something important to know, impulse is equal to the change in time. Sometimes you actually may see impulse as j of x, right? That could also be referring to impulse. So just as we know before, as we've done many times before, momentum is equal to the mass times the velocity. So we take those the initial conditions, right? This initial basically velocities and stuff, and we have 40 kilograms times the negative 30 meters per second, and we get negative 12 for the initial. And the final, we do the same thing, mass times velocity, and we get 8.0 kilograms times meters per second. Now to find the impulse, we find the change in time, which is basically just subtracting the um, the uh, the initial minus the final. Sorry, final minus initial, as we do here. The momentums we got there, and we get 20 kilograms by mass. Another way of writing impulse, another units of impulse is units times seconds. Same thing as kilograms times mass mc squared. So now impulse, now to find the average force, we have to use this equation that the impulse is equal to the average force times the change in time. You solve for average force. You would have to solve for average force. You would have to divide the impulse divided by the change in time, which we do here. 20 divided by 0.010 seconds, and we get 200 newtons. That is the average force, and that's all.